Hello, good day. I'm Byron Joseph Luzame, and I'm here to discuss about angular modulation and what is this all about. So, for the first part of my report, so let me talk first about angular modulation. So, what is angular modulation? Angular modulation is the process in which the frequency or the phase of the carrier varies according to the message signal. Moreover, it is the total phase of the carrier wave according to the instantaneous value of the modulating signal, keeping the amplitude to be constant. So, there are three types of angular modulation. The first one is the frequency modulation, next is phase modulation, and lastly, amplitude modulation. So, for the angular modulation is divided into three parts: frequency modulation and phase modulation. For the first, for the frequency modulation, it is the process of varying the frequency of the carrier signal linearly with the message signal. On the other hand, phase signal is the process of varying the phase of the carrier signal linearly with the message. Amplitude modulation is a modulation technique used in electrical communication mostly commonly for transmitting message with the radio carrier waves. So this is the feature of angular modulation. It's just like a wavelength. So next is, what is the difference between amplitude modulation or AM, frequency modulation or FM, and phase modulation or PM? So amplitude modulation or AM, a modulation technique used in electronic communication mostly for transmitting message with a radio wave carrier. One of the most straightforward ways of modulating a radio signal or carrier. It can be achieved in a number of ways, but the simplest uses a single diode rectifier circuit. So, as shown in the figure above, this is an example of uh, AM signal, the one on the last part of the signal. It is just like a waveform of amplitude modulation. So, in an amplitude modulation, the amplitude or signal strength of the carrier wave is varied in proportion to the message signal, such as an audio signal. This technique contrasts with an angle modulation, in which either the frequency of the carrier wave is varied as in frequency modulation as in phase modulation. Next is, what is frequency modulation? So frequency modulation or FM, it is the encoding of information in a carrier wave by varying the constant continuous frequency of the wave. The term and technology are used in computing, signal processing, and telecommunication. So FM radio broadcasting of an audio representing voice or music, the instantaneous frequency deviation. The difference between the frequency of the carrier and its central frequency is proportional to the modulating signal. So frequency modulation is widely used for FM radio broadcasting. It also used in telemetry, radar, seismic prospecting, and monitoring newborns for seizure via EEG, two-way radio system, sound synthesis, magnetic tape recording system, and some video transmission system. Frequency modulation and phase modulation are the two complementary principal methods of angular modulation. So, for the phase modulation, it is often used as an intermediate step to achieve frequency modulation. This method contrasts with amplitude modulation, in which the amplitude of the carrier waves varies while the frequency and phase remain constant. So for the phase modulation or FM, or sometimes used for analog transmission, but it has become the basis for modulation schemes used for carrying data. So for the phase shift keys, PSA is widely used for data communication. Phase modulation is also the basis of a form of modulation known as quadrature amplitude modulation, where both phase and amplitude modulation are powered to provide additional capabilities. Next is FM demodulator. As with any form of modulation, it is necessary to be able to successfully demodulate its recovered the original signal. With that said, the FM demodulator may be called a varied names including FM detector or an FM discriminator. There are a number of different types of FM demodulator, but all of them enable the frequency variation of the incoming signal to be converted into amplitude variation on the input. However, they are typically fed into an audio amplifier or possibly a digital interface if data is being passed over the system. So this is the formula for the modulation M. Modulation index M rather. First, the modulation index can be determined by measuring the actual values of the modulation voltage and the carrier voltage and the computing ratio. So this is the formula for the modulation index. M equals B over C, or in be specific, B max minus Pn, B minimum over B max plus B minimum. B max is also equal to Bc plus Pn, and B minimum equals Bc minus Bm. So for the FM modulation index, the frequency modulation index is the equivalent of the modulation index for AM, but obviously it is related in FM. So the FM modulation index is equal to the ratio of the frequency deviation to the modulating frequency. So for the formula for finding the M is frequency deviation over modulation frequency, wherein delta F is equal to frequency rather delta F is equivalent to frequency modulation and FM is equivalent to modulating frequency. Next is PM modulation index. PM change the phase angle of the complex envelope in direct proportion to the message signal. If M dash T is the message signal to be transmitted in the carrier onto which the signal is modulated, and here's the formula for the modulation and etc. So the mathematics of the spectral behavior reveals that there are two regions of particular interest. For the small amplitude signal, PM is similar to amplitude modulation and exhibit is unfortunate doubling of baseband bandwidth and for efficiency. Next is frequency deviation. Frequency deviation is used in FM radio to describe the maximum difference between an FM modulated frequency and a nominal carrier frequency. The term is mistakenly used as synonymous with frequency drift, which is an indented offset of an oscillator from its nominal frequency. So the ratio of maximum permitted frequency deviation Qmax to the maximum permitted modulating frequency or Fmax. So deviation ratio, or simply known as TR, this is the ratio of maximum permitted frequency deviation Qmax to the maximum permitted modulation frequency Fimax. So the worst case modulation index, which produces the widest output frequency spectrum, wherein DR or deviation ratio is equal to delta F max over Fn, wherein delta F max it is the maximum peak frequency deviation and Fm max it is the maximum modulating signal frequency. So this is the formula FM equation using Bessel function. So the equation Bs equals to Bc cos may be expressed as the Bessel function. So this is the formula for Bessel function, and this is the on the last part it is the simplified equation. So next is bandwidth. So the total bandwidth can be determined by knowing the modulation index and using the Bessel table. The bandwidth can be determined using simple formula. BW equals 2 times n times f, wherein n is the number of significant sidebands. So for the bandwidth, the total bandwidth can be determined by knowing the modulation index and using the Bessel table. The bandwidth can be determined using simple formula. BWN equals to 2n times f, wherein n is the number of the significant sidebands and FM is a maximum modulating frequency. An alternating way to calculate the bandwidth of an FM signal is used to Carson's rules, wherein BW is equals to 2 F max plus M max. So that's all for today. I hope you learned a lot and thank you and God bless. This is my reference, ma'am, and thank you and God bless.